Hello everyone, this is Dan Petrovich from DEJAN AI. We use machine learning to increase productivity and do unimaginable amount of workflow and productivity in SEO through use of lean and mean machine learning models. Today I'm going to take you through a little bit of our philosophy and some of the practical guides on how to do this yourself. First of all, how we think about use of these very large models is pretty much like this. You don't need an excavator to repot some daisies in your backyard, and for most SEO tasks you don't need to use very large, expensive and earth-polluting models. One such example is search query classification. Let's say you have many hundreds or thousands or even millions search queries that you need to classify for various SEO purposes. Typically people go commercial, non-commercial, commercial investigation, transactional, navigational, and so on. So you tend to gravitate towards ready-made solutions, software that's off the shelf, ready to go. I did a survey on how many people use self-made solutions and how many use software. And unsurprisingly, among my circle of followers on Twitter, a lot of people do their own solution. So that just says something about the adoption rate of self-made software for the purposes of classification. And here's how I look at the whole thing. You may have this neat-looking SaaS system, and you may have your clunky little self-made system, vibe-coded, that just barely works. But what we really know is that even behind that SaaS, there's a whole bunch of mess and problems and things that keep getting patched up in the background. Yours is free. There's no black box. You know exactly how it works. You can make it domain and task specific. If you need to change it, modify it, adapt it, you can do it yourself very easily. You can control design and the training of the models, and you know its strengths and weaknesses, but you don't really know how good or how bad something else that somebody else has made is. So how to get started? First step is already done for you. You don't really need to do this part, but just in our workflow to understand what pre-training is. This is where models basically learn the language. This is something like BERT already understands English, and then you fine-tune it for a specific task. Fine-tuning is the process of taking a pre-trained model and teaching it to do this one thing that you need it to know really well for you. So fine-tuning process is based on the fine-tuning data, and data generation process is really most of the work, I would say. Once you fine-tune the model, you validate it, and you run inference. Basically, you crank it up and you run predictions using the model that you've just fine-tuned. On Hugging Face, there are a million ready-made models. Some of them are bad, some of them are good. You can list them by popularity. There's a ton of things you can do there. Literally employ models that can do out-of-the-box sentiment analysis, classification, named entity extraction, all sorts of things that are immediately useful for SEO tasks. This is what it looks like. So you have various tasks like text classification or token classification. We can go into those bits and pieces a little bit later. One of the favorite tasks for me personally is text classification, because the model takes a whole text sequence and classifies it as one thing or the other, or multiple things. So here I'm searching and filtering. There's 70,000 models ready to go. You can sort them by popularity. You can do a keyword search, find what you want. So one such model is the one that we've trained and released. This model does one thing and one thing only. It tells you the intent of the search query. what did the user want when they typed that into Google. So this model doesn't do language, it won't chat to you, it won't do anything else. It really sucks at everything else, but it's really good at determining the intent of a query. And that's the whole point. And this model is under 1 gigabyte, and it didn't take a whole month and killed half the planet to train. So, how to get started. This is the prompt that will nudge you in the right direction, I would say. Start a step-by-step guide on setting up my system for local model inference. This is just to get you going, running the models locally. Here's another one. Write Streamlit inference code for DEJAN SEO /intent Excel. This specific instruction will get your GPT or Gemini or whatever gigantic model you use, like Claude, to actually take this model and write a little Python code to make it run on your computer. So this is what it looks like. You run that, pops up with a little interface, and it predicts if it's 0 or 1. That's what it does. And then you can give it a name. So basically, is it a commercial? Is it non-commercial? Is it of that label type or of the other label type? So you could say, visit this URL and grab the labels to improve UX. And that's the URL where we actually list the labels that we used for the training of this model, such as commercial, non-commercial, navigational, instructional, and so on. And what you were previously seeing as label 0 is now commercial. Score 1. Model is 100% confident that that particular query is of commercial nature. Here's another prompt. Return probabilities for all labels and show as a histogram. So now your little app running the model that we published for everyone to use for free can tell you the probabilities of each of the labels that the model is trained to classify for, the probabilities of each one. So you're now no longer classifying search queries into one particular label, you're classifying it into a range of probabilities with different confidence levels, giving you that nuance. Here's another one. Add query bulk upload from CSV or TXT file. Remember, you're just building your own little app now using the model that we've trained and published. So now I can do the drag and drop into this interface and do query classification at scale. Some other ideas: produce graphs and visualize the results, connect to Google Search Console via API, and add more metrics to it. So, already doing machine learning stuff. You're not training models yet, but you're running the models that somebody else has trained. That's the really first step you need to take. So you're at this very stage. You're playing with pre-trained models and even fine-tuned models. But the next step for those who are up for a challenge, generating your fine-tuning data. So your options for getting the teaching material to train or fine-tune a model for a particular task or purpose, you have really two options: organic or synthetic data. Organic data is really valuable because it's real human annotations, labeling, interactions, whatever it is. And synthetic data is something that you've asked a big model like Gemini, GPT, Claude, Grok, and so on, or even smaller open source models like Gemma, which is excellent for synthetic data generation. We'll use hybrid. Start with organic, show it as some examples, and get some synthetic queries mixed in with that to broaden your training data set. So we've got human labeled organic queries, LLM generated label queries, and a bit of a mix. So one, of course, is time consuming and can be a little bit inconsistent. And then we've got the second one, which can be really quick. Not as diverse as human stuff, but very, very consistent in its nature. And of course, hybrid, a bit of a balance between the two. So the next thing is to organize that information to understand how we're going to train this model. So first thing we do is define the labels. So our objective now is to create a classifier. We're classifying the query intent uh, model. So we're going informational, navigational, commercial investigation, local, visual, video, voice search, whatever. So you can do few shot, show the big model some and let it generate some for you. And here's me in AI Studio instructing the model to generate the data for me. Get the code, use my API key, and off we go. I can generate a massive amount of training data using this. So there we go. So I've got training data.csv. Its structure is really simple. I've got query, I've got label, and I've got some search queries there, and each one is labeled with its ID. And each ID is really just the representation of what category of classification we're going for with that. So the next step is fine-tuning. So we've got the training data, which we will split into two parts, training dataset and validation dataset. We will pick our base model. Absolute smallest model you can start with is Albert. My personal favorite is Microsoft's DEJAN version 3. Works really, really well on a variety of classification tasks. And then you assign it a training task. So in this case, that's text classification. There are some things called hyperparameters like learning rate, number of epochs you want to train it for, and so on. If you're not really sure about these, you can just go with default stuff that GPT or other model that's going to be coding your script decides for you. Might help if you tell it your particular setup, like what type of machine you have locally that you want to run this training on. One thing that's quite important is to dip your finger in the cooking and have a taste as it goes. So while your model is training, you want to sample to see how the quality of that model is progressing. And an excellent framework for that sort of task is weights and biases. Look them up and sign up for the account and use it to log metrics relevant to your particular training. During the training process, one thing that's quite important is to save and checkpoint the model at different intervals during training, and of course saving the final model so the thing you've trained at the end is actually saved and ready to use. Sometimes you'll find that if you've trained for too long, your model overtrains and it's not very good at generalizing. That's where you can go back to a certain checkpoint that you've saved, kind of like bookmarking along the way, and making sure that you have something you can run even if your final model is overtrained, or as we say, overfitted. So how do you get started with the whole thing? Well, again, we are not going to be learning how to code. We'll just simply, as they say, vibe code this whole thing. Write code for fine-tuning a transformer model for search query intent, multi-label classification using training data.csv. And it'll smash out a good script for you. Might have a few errors along the way, depending on your specific environment. You also may have to set up basics, Python, basic use of command line, and so on. What I tend to do is I tend to also provide a sample from my training data, just so the model can see what's inside. So query, classification as headers, how to make a smoothie, comma, 1. And that's almost sufficient enough data for a model to create a basic training script in the first go. Of course, you can expand on all this. If you know what you're doing, I would recommend you play around with the basics first, but let's just go through it and describe what I've actually put in this more elaborate prompt. So here I'm saying write code for fine-tuning Albert base v2 for text classification. Train and val split is 9:1. Basically, we're taking 90% of the training data to train the model, and we're going to use 10% of the data to test the model. We'll never show that data during the training, so we can One thing I like to do is ask the model to code in such a way that all the tweakable little parameters are sitting at the top, so I can open the code and change parameters if I'm trying to rerun the training. For example, learning rate, the batch size. Batch size is important if you're using a GPU, and you want to make sure that you're not exceeding your GPU VRAM. So for example, if you have a smaller GPU, you might downsize your batch, in a sense, how many training samples you can fit in one round. So 12 might fit in a bigger GPU, or 8 or 4 in a smaller one, or if your data sample is really small, then you can get by, having 32 samples or 64, even 128 samples in a batch. Training for 4 epochs. There's no right or wrong. You can keep training and just monitoring the metrics using weights and biases. And that's why I've specified my username there, so that can be incorporated into the training script. And I'm saying log every step. You can log every 10 steps or every 100 steps. That's basically how often it'll make a little data point during the training period. I'm telling it to checkpoint or save a little model every epoch. That's basically, epoch is one round of going through the whole training data set. And if you, for example, if you train it for 4 epochs, the model will be training 4 times on the entire data set. And of course, save the best model at the end with early stopping criteria of 3. That means that if model's not making any progress using the validation metrics that we've specified, the script will just stop training at that point. So in this case, we're using validation loss as a criteria. Maximum sequence is 18. In this case, we're using 18 tokens for the maximum length of that training sample. Of course, if you're training for something longer than search queries, you will want a lot more token in there. Warm-up steps 100. This is one quirky thing with training models. They don't like to be trained very aggressively at the very start, so you want to ease into the training to avoid things like exploding gradients and whatnot. The cross entropy, you almost don't need to specify. I think the GPT, Gemini, and Claude will just by default select that option for you for this particular task. Gradient clipping 1, that's to control something we call gradients, which tend to go very high and can disturb the training if the model is not finding the optimal training process at that time. So clipping that ensures that you don't lose the model training halfway in because the one step took it too far into some space of optimization. And again, we're providing a sample of our data. So we've got the model, we've got the task, we've got the training validation split, we've got our learning rate, batch size, number of epochs, logging, we've got checkpointing, we've got saving of the model, early stopping, maximum sequence, warm-up steps, loss function, gradient clipping. That's more than enough. Like I said, you can get by on much simpler instruction, something like that. Get you going in the very start of your model training journey. So some of the prompt enhancements that you can add is adding more specific validation metrics. This is the sort of like have a taste to see what the model is doing, and or we could say finger on a pulse while it's training. So F1, precision, accuracy, and recall are sensible things to include during the training of the model, and of course seeing those metrics at the end. For those who are wanting to go into more advanced things, you can do hyperparameter sweeps. So for example, your learning rate or batch size, you can automatically swap them around and change the values. I would advise to experiment manually at the very start. Once you know what you're doing, you can set up hyperparameter sweeps in a certain criteria and have that model training run on an ongoing basis, experimenting essentially to see what hits the sweet spot. We're truncating the long sample, so if there's an outlier search query that exceeds the length that we specified, it'll just clip it. And if there's something that's too short, it'll pad it. And that means that they're all equal, they're all of the same size when they get fed into the model. It's just something to do with the architecture of the GPUs and how they like data fed into them. One thing to keep in mind is that if you have overrepresentation of a certain type of data or a certain label in your data set, it's good to mention that while you're designing the script, so the model can add weight strategy to prevent one type of data overpowering the other type of data during the training. And of course, we've got some regularization strategies which help the model learn better by making it more difficult to learn. I'm not going to go into that. You can look those strategies up yourself. Most people will use CUDA GPU setup, especially those using PCs. So we've got your Python code on top of PyTorch, on top of CUDA, on top of your GPU. So if you're a gamer, if you have a powerful laptop or a desktop with a GPU, you're pretty much set. Another ecosystem, which I'm not familiar with, but of course is perfectly suited for training models, is an Apple ecosystem. So if you're seeing something familiar on the screen, go for it and give it a try. So this is what a fine-tuning script may look like. We go Python train.py, hit enter, and there's weights and biases showing beautiful graphs. We're here seeing the training loss. So basically the amount of errors the model is making at every next step during the training process is minimizing. And we can see that this is quite a healthy learning curve. The number of errors is decreasing. The optimizer is doing its job. We're finding the optimal solution in the space we're searching of all the probabilities. One thing to look out for is, for example, if we're running training of the model and everything is going well, and then suddenly you start to see a little increase or a spike in your validation, that's a sign that you've probably trained for too long, and maybe you should go back to a checkpoint in a previous stage. And of course, we've got the recall, precision, F1, and accuracy for our model. So here we're looking at a healthy training curve. If you stop it at this point, you're underfitting because you haven't trained it quite enough. This is probably a healthy look. But if you have something like that, a little bit unstable, that's a bit of a warning sign. And if you keep training and model is starting to memorize things, basically learning for exam, but not being able to apply once it's get a job, or as we say, inference. If the model starts memorizing things, it's not going to do very well on generalization, and that means this model is no good anymore. You want to go back to a point where it was still generalizing pretty well. So picking your best models. If you're wondering what sort of hyperparameters you actually did use to create a good version of the model, in those experimentations and little tweaks that you did there, including batch size, how many epochs to train on, the learning rate, those are quite easy to influence the quality of the model. So you can easily have a look at a chart like this in weights and biases and effectively see what learning rate, what gradient clipping, what basically a set of parameters have created the best model. So this is the model with the lowest final loss, and I can see its exact parameters. Of course, when you highlight over this line, you will see it light up, just like I did with this one here. And you will know exactly what hyperparameters really worked well. So that's how it looks like when you highlight one particular thing. So here I can see my learning rate that's worked really well, how many steps I trained it for, and what sort of metrics I got. Okay, so let's say the model's cooked and ready to go. So you've saved the model, it's there, it's a file on your computer now, and you can run the model. Well, that takes us back to the original step where you learn how to use somebody else's models and run them to perform a useful task. You can run your model locally, or you can upload it to Hugging Face. Here's how it works when you upload it to Hugging Face. You can upload it privately for your own use, or you can set it as public for others to benefit from the training. So you give it a name, create model, add files, upload everything, and you can, that's how it looks like. So you have your model files and everything, all the config files, tokenizer config, and you're ready to go. So production deployment, probably the fastest way to get it going is running on your local machine, or Hugging Face Spaces if you want to share it with your team. And of course, if it's in a more commercial setting and proper deployment, you probably use something a developer would use, like a container or a cloud solution. So this is what spaces look like. You can create your space and simply run the model. So here's Linkbird, our token classification model, which is capable of recognizing when a good link moment happens in plain text. So we feed it text and it can tell what should be a link without seeing the links in that text. And then you can embed that space, put it in your HTML, and run a little tool or a demo for your team, or to showcase your capabilities or perform useful SEO tasks. So let's take a look at some examples of custom-built models in our workflow. So we've got natural link integration. We've got click-through rate prediction. We've got spam detection, link spam detection. We've got query intent classification, sentiment analysis, and many, many more. So we can take one model and increase the productivity of our team by many, many times. We use it for internal link optimization, for content optimization, for link integration, prospecting outreach, traffic forecasting, scenarios and projections, opportunity detection, algorithmic impact and correlations, click-through rate optimization, and of course reporting and data visualization. Claude is particularly good to take the outputs from your model and wrap them up in pretty dashboards and things. All right, well, that's me. Now it's your turn. If you get stuck, reach out to me and I'll help you out. See you guys. Bye.